Welcome back to the deep dive. Today we're going to get into a question that sort of bridges two very different worlds, marine biology and, well, high-stakes finance.
Yeah,
How do you assign a tangible, hard dollar value to something as ephemeral as an environmental warning?
that is the core question. This whole deep dive is built around a really fascinating piece of research. It's titled Assessing the Value of Harmful Algal Bloom Forecasts in the Pacific Northwest.
Okay.
It's led by Dijon and colleagues from the Woods Hole Oceanographic Institution. And it's frankly a scientific business case for being prepared.
Our mission then is to unpack this research and show you exactly how they went about scientifically quantifying the economic worth of being ready for these toxic, unpredictable marine events.
Right.
Ultimately, we want to deliver a clear understanding of this crucial concept they use called the value of information, or VOI.
And the reason this research is so urgent is the central issue they're investigating, harmful algal blooms, HABs. For the last 30 years or so, these blooms have caused chaos along the Washington and Oregon coasts.
Because they produce this neurotoxin.
Exactly. Domoic acid.
Mm.
It causes amnesic shellfish poisoning, and its presence can, instantly shutter entire fisheries, which just devastates local economies.
Right. So let's set the stage a bit. When we talk about the Pacific Northwest coast, we are not talking about small fishing operations.
No, not at all.
We're talking about massive, multi-million-dollar industries that are directly exposed to this risk.
Precisely. And if you look at the numbers for Washington and Oregon, you really start to grasp the scale.
Okay.
Take the recreational razor clam fishery in Washington. It is a huge economic engine for coastal tourism. It generates something like $48 million a year.
$48 million. Right.
And that's just in recreational trip spending. And here's the critical part. That money often comes in between October and May.
The off-season for tourism.
The off-season, yeah. So those clamming trips are vital income when the summer crowds are gone. But the commercial side is even bigger.
Which is the Dungeness crab.
It is the largest commercial fishery in the region. You're looking at huge average annual revenues. I think it's roughly $61 million in Washington and $68 million in Oregon.
So combined, that's about, what, $130 million a year?
Almost. About $129.2 million per year on average. And that money supports thousands of jobs, from the boats to processing and distribution.
So when the stakes are that high, a sudden, invisible closure from a HAB event could trigger an economic earthquake. And this isn't just a hypothetical problem, right?
No, not at all. It's a recurring crisis. The historical impacts are dramatic. I mean, look at the Washington recreational razor clam fishery back in 2002.
What happened then?
A major HAB event caused the entire season to be canceled, a preseason cancellation, before it even began.
Wow.
So the number of clamor trips, which were typically over 300,000 a year, just dropped to zero overnight.
Zero. I mean, you can just imagine the shockwave that sent through the restaurants, the hotels, all those coastal towns.
And the commercial sector suffers just as much. The big one everyone remembers is the 2015 HAB event.
Right.
That single event caused the Dungeness crab revenue to drop by a staggering 67% compared to the long-term average.
67%. So you're talking about millions and millions of dollars just wiped off the books.
Exactly. And beyond the pure economics, you have to remember HABs compromise public health, they threaten food security, and they disrupt culture, especially for tribal commercial fisheries like the Quinault Indian Nation.
That context really makes it clear how environmental stability is directly tied to economic stability. So if that's the problem, what's the tool this research focused on?
The tool is the PNW HAB Bulletin. It was first launched in 2008, but it really gained renewed focus after those catastrophic 2015 closures. It was brought back in 2017 to, proactively address the risk.
And what does this bulletin actually do? Is it just a sign that says, toxins are here?
It's much more sophisticated. It provides timely forecasts to managers. And that's crucial because a forecast lets you make proactive decisions.
So you can do things like increase monitoring in one specific area, or maybe delay a season opening by a week.
Exactly. Or even do selective harvesting at beaches that appear safe. It completely shifts the strategy from reacting to a crisis to, predicting it.
Which brings us to the methodology. They needed a solid argument to justify funding this thing long term. They had to measure this value of information. How on earth did they do that?
Well, the fundamental goal was to quantitatively estimate the net economic benefits. They needed to prove to stakeholders that the investment in the bulletin literally pays for itself.
Okay, this is where it gets really interesting for you listening. Let's break down this core concept. How do you calculate the value of simply knowing something ahead of time?
They used a Bayesian decision model framework. And I know that sounds complex,
It does.
but think of it less like calculus and more like a sophisticated way of mapping out risks and rewards. The basic idea of the value of information, the VOI, is just the difference in expected economic benefits when you make a decision with a forecast versus without one.
So it's measuring how much better your decision is when you have the crystal ball, even if that crystal ball isn't 100% accurate.
That's a perfect way to put it. Imagine a manager deciding whether to open a beach for clamming. Without a forecast, they're just relying on historical data, maybe some current water samples.
And they have to err on the side of caution.
Always. Which can mean unnecessary closures, which of course costs the economy money.
Right.
So this model, it maps out 4 possible outcomes. First, the HAB event happens and they take action. That's a good outcome. Second, HAB happens and they don't act. Catastrophe.
Yeah.
Third, no HAB and they don't act. That's the optimal outcome. And fourth, no HAB, but they still act and close the fishery.
Which is the unnecessary cost you just mentioned.
You've got it.
Okay.
The forecast, even if it's only, say, 90% accurate, lets the manager shift their actions away from the catastrophe and minimize that unnecessary closure cost. The VOI captures the dollar value of that better decision-making.
And what's amazing here is the complexity of what they're actually forecasting. This is not just a weather report.
No, not at all. The bulletin is this fusion of multiple science streams. It combines offshore monitoring, each monitoring of the pseudoniscia cells.
That's the algae that produces the toxin.
Right. Then it adds in satellite remote sensing, massive ocean models, weather forecasts, and even high-frequency radar that tracks ocean currents. It's a huge undertaking.
And I assume all that is necessary because the coast is so chaotic.
It is. The conditions change extremely quickly. We're talking shifts happening in just 3 to 5 days. Plus, the biology itself is tricky. Lots of species of pseudonychia are always there, but they don't always produce the toxin. The forecast has to distinguish a harmless bloom from a toxic one.
Okay, that context makes the expense sound totally justified. So let's get to the central finding. Did they prove that this expensive, complex system actually pays for itself?
The answer is an unequivocal yes. The central finding is that ongoing financial support of the PNW-HAB bulletin is entirely economically justifiable.
Okay, so give us the quantitative proof. The cost versus the value it generates.
All right, the estimated annual cost to maintain this entire warning system, the modeling, the sampling, everything, is about $1.2 million per year.
$1.2 million invested annually. And what's the benefit from that, according to their simulation?
So using a baseline simulation, they assumed one major HAB event every 6 years, which is historically accurate, and a forecast accuracy of 90%.
Okay.
Under those conditions, the system generates a value of information, or VOI, of $1.9 million annually.
Wait a minute. So you spend $1.2 million and you generate $1.9 million in reduced economic losses.
That's right.
That's a $700,000 net positive return every single year.
That's the estimate, yes. And it provides that quantitative justification they needed. The research basically says the system pays for itself as long as major HAB events happen more frequently than once every 7 years. And history shows they do.
So what makes the value of the forecast go up? What are the key levers in the analysis?
There are 3 main factors, which is important for future planning. First, the frequency of the HAD's events. The more often it happens, the more valuable the warning is.
Makes sense.
Second is the precision of the forecast. If they can push accuracy above 90%, the VOI goes up significantly. And the third factor is how many different sectors benefit from it.
Which means as climate change potentially increases the frequency of these blooms,
Right.
and technology improves the accuracy of the forecast, the value of this bulletin is only going to grow.
It's essentially a growth stock in environmental resilience.
So let's talk about how this value is actually realized on the ground. How does this forecast translate into tangible benefits for managers and industries?
For managers, it enables much better decision-making.
Yeah.
It lets them implement timely, targeted closures to protect public health. But just as importantly, it helps them prevent unnecessary closures.
So they can maximize the number of days that beaches and fisheries are safely open.
Exactly, and the research gives a great example of this. The bulletin gave an advance warning that an area was at risk right before a planned razor clam harvest.
Okay.
So managers scheduled extra, unscheduled tissue sampling just in that zone. The tests came back and confirmed the area was actually safe. The harvest went ahead as planned.
Without the forecast, they would have just closed it out of caution.
Very likely, yes.
Yeah.
They would have lost all that crucial income. So the forecast maximized the safe harvest period.
And for the private sector, the fishers, the tourists, what are the direct benefits for them?
Well, commercial fishers get critical lead time. If they know a delay is coming, they can hold off on costly boat repairs or adjust staffing. For recreational folks, it's simpler.
Yeah.
They see the bulletin online and don't drive 100 miles to a beach just to find a closure sign. It saves them time, gas, and a lot of frustration.
That really highlights the difference between knowledge and guesswork. Now, for the critical thinking moment, the study is robust, but the researchers admit there are limitations. What's missing from that $1.9 million benefit figure?
This is a crucial point. They are very clear that the 1.9 million is a lower bound estimate.
A lower bound.
Yes, because it is strictly limited to the direct economic impacts on only two sectors, the commercial Dungeness crab and the recreational razor clam sectors.
So they haven't counted the ripple effect through the wider regional economy.
Not at all. The estimates completely exclude the broader economic multiplier effects. So they aren't including the losses for crab processing plants or the trade and transport sectors or, the local hotels and restaurants that lose business. The actual economic loss avoided is likely much, much higher.
And what about the non-monetary costs, the things you can't put a dollar value on?
Precisely. They don't quantify the severe sociocultural disruption to tribal nations. And maybe most importantly, they don't include the reduction in public health costs.
Preventing illnesses, hospitalizations.
Exactly, and preventing a single widespread outbreak could save millions on its own.
So the true economic value of this $1.2 million investment could easily be double, maybe even triple, the $1.9 million they reported.
That's the clear implication. The study acts as a very conservative floor, which makes the economic case for continuous funding pretty much irrefutable.
Looking ahead then, where does this kind of research take coastal management?
It really provides the template. The future relevance of these programs is only going up. As we said, with the expected increase in HAB frequency from climate change, forecasting becomes a necessity, not a luxury. So its economic value will just keep increasing.
Which really solidifies the conclusion. Public investment in these HAB forecasting programs is strongly supported by the data. This isn't just good science, it's a necessary form of insurance.
Absolutely. The final thought, really, for future research is about scaling this up. The lessons learned here in the Pacific Northwest need to inform global strategies. Future work needs to focus on making these systems cost-effective and sustainable worldwide. It's about exporting this model of successful environmental economics.
That is a phenomenal look into the critical business case for predictive science, a really powerful deep dive into the value of information.
Thank you for joining the Deep Dive.